Now we are in the last topic for plane in space, which is how to find the shortest distance, where there are three cases will be considered. The first one is to obtain the distance from a point to a plane. Okay, let's say we have a point to a plane, so we want to find the shortest distance to a point to this point, let's say P, to this plane, pi. And then we want to consider the distance between two parallel planes. Let's say we have pi 1 and another one is pi 2. So we want to find the shortest distance between these two planes. And the last one is case where we want to find the distance between two skewed lines. So something like this. So the lines is in the planes, and then we have another lines which is somewhere like this. So we want to find the distance between these two skewed lines. Okay, so for these three cases, for the first case where we want to find the shortest distance from a point, let's say P, where P is given as x1, y1 and z1, and the equation of a plane is ax plus by plus cz equals to d. So the formula to find the shortest distance from a point to a plane will be equals to the absolute of ax1 plus by1 plus cz1 minus d. So we bring d to the left hand side, divide by square root of a square plus b square plus c square, where a, b and c is taken from the normal vector from the plane. So this is the formula to find the shortest distance, or we write it as d, okay, from a point to a plane. Okay, for case 2, where we want to find the distance, the shortest distance between two parallel planes, given that the first plane is equals to this equation, where the difference is that the value of d1 and the value of d2. And the second plane is ax plus by plus cz equals to d2. So the shortest distance between these two parallel planes is equals to the absolute value of d1 minus d2 divided by square root of a square plus b square plus c square. And the last one is that if we want to find the shortest distance between two skewed lines, it can be obtained by evaluate the distance between two parallel planes that contain the two skewed lines. Okay, so I'm going to show you example for each cases so that you can understand more about this. First example, given find the shortest distance between the point and the plane. So this is for case 1, where the formula to find the point is t is equals to ax1 plus by1 plus cz1 minus t over a square plus b square plus c square. Okay, so we have two questions here. First, we try to solve for A from point P. So we have P is 1 minus 1 and 2 to the plane 3x minus 7y plus z equals to 5. So we have plane, equation of plane, which is 3x minus 7y plus z equals to 5. So here, from here, we identify this is our point. So here will be our x1, y1, and z1. And from the equation of plane, where this is our A, B, C, and D. So now from here, we can just substitute into the formula of shortest distance. So we have D is equals to absolute value where A is equals to 3 and x1 is given from the point P. So we just multiply with 1 plus B, which is negative 7, times with y1, negative 1, and C is 1 times with z1, which is 2. And then our D, remember that we have to bring our D to the left hand side. So this will be minus 5. Divide by square root of A square, which is 3 square, plus negative 7 square, plus C, which is 1 square. So by calculating this, we will get 7 over square root of 59, which is equals to 0.9113. So the distance between point P to plane is equals to 0.9113. Now let us proceed with question B. Find the shortest distance between point P. So we have P is negative 1, 2, and 1. And then with plane, so given the plane is passed through the point. So let's say we have point here. We denote as Q as negative 3, 5, and 1. And we have normal vector, which is equals to 3i plus j plus 5k. Okay, what we need to do is that first we have to identify the equation of a plane, of the plane pi. So we have here point and we have normal vector. So from there, we can obtain the equation of a plane. Since to obtain the equation of plane, what we need is a point and also a normal vector. So here, our Q and N here, this is as X node, denote as Y node, and this is Z node. And this normal vector is defined as our A, B, and C. So now we know that the equation of a plane is given by this formula, where AX plus BY plus CZ equals to D, where D is equals to AX node plus BY node plus CZ node. So in order to get the equation of plane, what we need to do is just substitute all these value of A, B, C, and X node, Y node, and Z node into the equation. So we have our A here is 3X plus B, which is 1 times Y, plus CZ. So C is 5Z equals to D, where D is equals to this equation. So we have our A times with X node plus B, which is 1 times with Y node, and C times with our Z node. So we have minus 9 plus 5 plus 5. So our D is equals to 1. So the equation of a plane is equals to 3x plus y plus 5z equals to 1. So now we can find the distance of the point and the plane, where this is equals to ax1 plus by1 plus cz1 minus t divided by square root of a square plus b square plus c square. So this will be equals to, so now our a is this one, a, b, c, then our a is 3 times with, so our point here, p, this one is as our x1, y1, and z1. So substitute into the formula of shortest distance. So we have 3 times -1 plus b, which is 1 times y1, plus c, which is 1 times, this is 5. 5 times with 1 minus d, where d is equals to 1, divided by square root of 3 square plus 1 square plus 5 square. Then we get the value of the distance, which is 3 over 35, which is equals to 0.5071. So we have solved the distance, the shortest distance for B. Another example is find the shortest distance between planes, these two planes. So we have our first plane is equals to x plus 2y plus 3z equals to 5. And then our second plane is equals to x plus 2y plus 3z equals to 10. So from here, you notice that since this is the equation of a plane, and the constant of x, y, and z is actually our normal vector, which is a, b, and c. So the normal vector for the first plane is equals to I plus 2j plus 3k. And same goes with the normal vector for plane 2, where the normal vector for plane 2 is also equals to I plus 2j plus 3k. So now, since the normal vector of these two planes are the same, are equals, so it means that our normal vector of 1 equals to normal vector of 2, because since here is the same value, the same equation of normal vector, so we can say that this normal vector or the planes are parallel. So since the planes are parallel, we can find the shortest distance between these two parallel planes, given that the equation of plane 1 and plane 2 is this. So the formula for finding the distance falls under case 2, where the formula is d1 minus d2 divided by square root of a square plus b square plus c square. So here, what we can do is that we just substitute the value of d1, where d1 is equals to 5. So this is our d1 and this is our d2. So 5 minus 10 divided by square root of a square, which is 1 square plus 2 square plus 3 square. So this will be -5 divided by 14. So since it is absolute, so the final answer will be positive. 5 over square root of 14. Or the answer will be equals to 1.3363. So the shortest distance between these two planes is equals to 1.3363. Okay, let's try the last example, finding the shortest distance between the skewed lines. So this falls under case 3. So we have here the equation of line 1 and line 2. So first I want to draw the figure of this so that you can understand more, you can imagine what I'm going to talk about. So first is the first plane, where the first plane consists of line L1. Let's say something like this, okay? And then we have the second plane, where it is something like this. So the line 2 is somewhere like this. So since it is skewed, so it's not the position is different with each other. So our aim is to find the shortest distance between these two skewed lines. So here we have our line 2 that lies on the plane 2. Okay, here we have the equation of line 1. So I want to list out all the important thing here, where in line 1 we can identify the point 1 that lies on the line 1, which is L1. So from this equation we know that the point can be taken from this value, which is 1, -1 and 2. So point can be represent 1, -1 and 2. And another important thing is that the vector that is parallel to L1 can be obtained from this value, where vector 1, which is equals to 2, 1 and 4. So the vector 1, it is parallel to L1. So if I draw this, is something like this. And our V2 is parallel to line 2. So here for L2, we can also identify the point that lies on line 2, which is equals to -2, 0 and -1. And then the vector 2, which is equals to 4, -3 and 1. So this is all the important parts in line 1 and L2. So our aim is that we want to find the shortest distance between the skewed lines. But we have learned before that we can find the shortest distance between a point to a plane. So I'm going to use that idea for solving this kind of problem. So in order to find the shortest distance between a point and a plane is that what we must have the value of ax plus by plus cz. So this is s1, y1, z1 minus t divided by square root of a square plus b square plus c square. So our ABC here is the normal vector from the plane. Okay. And our x1, y1 and z1 is the point that is from another plane. So here, what I want to focus is, I want to identify which point that I want to focus on and which plane that I want to focus. So for this problem, I want to make that I want to choose the point from the plane one. So I want to choose this P1 as our point, and the plane is from plane 2. Okay, we have only the equation of line 1 and line 2. And the point here, there's no problem anymore because we have identified our P1, which is 1, minus 1, and 2. So the next thing is that we have to identify what is the normal vector for plane 2. What we can do is that we have the vector of 1 and vector 2. From here, we can identify the normal vector that is orthogonal to pi of the plane 2, where the cross product of v1 and v2 will produce a vector that is orthogonal to plane 2. So here we can solve this, where v1 cross v2 will be equals to I, j, and k. So this will be 2, 1, 4, and our v2 is 4, minus 3, and 1. So solving this for I, first for I we close the row for I. So we have 1, 4, minus 3, 1, minus j. So we close this. What is left is 2, 4, 4, 1, plus k. So we close this row. So we have 2, 1, 4, minus 3 times with k. Then find the determinant. So we have 1 minus 4 times minus 3, which is minus 12, I, minus with 2, minus with 16, j, plus with minus 6, minus 4, k. So the final answer will be 13I plus 14j minus 10k. So this vector is the normal vector for plane 2. So now we have identified our A, B, and C. Next is that we need to identify the equation of the plane. So the first one is identify all this, and then this, and then this, is that identify the equation of plane 2, because here we have our ABC here. So our A will be 3, 13 times with x. So this will be 13x plus by, which is 14y minus cz, plus cz, which is 10z, which is equals to d, where d is equals to ax naught plus by naught minus 10z naught. So our x naught, y naught, and z naught can be taken from the point that lies on plane 2. So we just substitute the value of x naught with minus 2 plus 14 times 0 minus 10 times minus 1. So now we have equals to 13x plus 14y minus 10z equals to minus 16. So now here we have this equation of plane 2, and then we can now solve the shortest distance, where d is equals to our ax plus by plus cz is this 13 times with x1, where x1 is taken from this point P from the plane 1. So we have 1 plus 14 times with negative 1 minus 10 times 2 plus 16 divided by the square root of 13 square plus 14 square plus negative 10 square, where this will be negative 5 divided by square root of 465, since this is absolute value. So the negative value will be positive, and the final answer will be 0.2319. So the shortest distance between these two lines is equals to 0.2319. Remember that you also can use the difference value, where you can use the point from plane 2 and the plane is from B1. But at the end, the final answer will be the same.